So, if you wake up inexplicably furious today, the medical data suggests you actually shouldn't check your head. You should check your stomach.
Yeah, which is completely counterintuitive.
Oh, totally. Because usually, when we try to analyze a bad mood, we look for some logical external trigger, like, I don't know, a spilled coffee, a flat tire, maybe a passive-aggressive email from a colleague.
Right. We default to this really clean cause and effect narrative.
Exactly, because it's comforting. It feels good to have some external variable to point at and blame for your internal state,
Well, we're pattern-seeking creatures, fundamentally. When your internal environment feels chaotic, finding an external reason for that chaos, even a really small one, it provides a sense of control. Even if that reason is completely disproportionate to the actual anger or sadness you're experiencing.
But the real problem comes up on those days, and every single person listening to this knows exactly the experience I'm talking about, where you wake up and that cause and effect narrative just completely shatters.
Right, there is zero external justification for how you feel.
Nothing went wrong. But you're still carrying around this heavy, unexplained sadness or just this deeply volatile irritability.
And the frustration in those moments is so palpable, it usually turns inward too. It leads to this cycle of unwarranted self-blame where people just feel like they're failing at managing their own minds.
Which is actually the exact core focus of our deep dive today. So, welcome to you, the learner. We are unpacking a genuinely mind-blowing stack of clinical research today to understand these unexplained mood swings at a cellular level.
It's a really exciting topic.
It really is. And the mission here is to shift your perspective entirely. Instead of looking at daily stressors or, psychological resilience, we are taking a journey straight down into the gastrointestinal tract.
Right, because the research makes this incredibly compelling case that our emotions are not just these wild, untamable abstractions.
They're highly specific chemical expressions. And more importantly, they are expressions that you can directly stabilize just by providing your body with the correct nutritional building blocks.
Exactly. But to really understand how that stabilization process works, we have to isolate the biological root of these emotional fluctuations first.
Right. And all the data points consistently to one primary neurotransmitter, right? Serotonin.
Yeah, serotonin. It essentially acts as the central nervous system's master stabilizing chemical. It's responsible for signaling safety and satisfaction throughout the body.
Right, but the cultural assumption is always that, well, because serotonin dictates our mental state, it obviously has to be manufactured up in the brain.
Which makes sense intuitively, but the research highlights a starkly different reality. Up to 95% of the body's serotonin is synthesized in the gastrointestinal tract.
Oh, wait. 95%?
Up to 95%, yeah. Down in the gut.
So when people dismissively say, oh, it's all in your head, it's actually almost entirely in your gut. That's crazy.
It really forces a complete paradigm shift in how we view mental health. The brain is essentially just the end user of this much larger systemic manufacturing process happening in your stomach.
But serotonin doesn't just, magically appear, right? The body can't synthesize it out of thin air.
No, absolutely not. It requires a very specific biological precursor. And that is an essential amino acid called tryptophan.
And because the human body cannot produce tryptophan on its own, you have to get it entirely through your nutrition.
Exactly. And once you ingest it, this highly complex microscopic assembly line just fires up. Your gut microbiome works in tandem with these specialized enterochromaffin cells that line your gastrointestinal tract.
Enterochromaffin cells, okay.
Right, and these cells basically extract the tryptophan and convert it into a compound called 5-hydroxytryptophan, or just 5-HTP for short.
Okay, I've seen that on supplement bottles.
Yeah, it's a super common. And then that 5-HTP is synthesized directly into serotonin.
And the implications of that pathway are just massive. Because once that serotonin is manufactured, it utilizes the vagus nerve, which acts like this massive neural superhighway connecting the gut up to the brain to send those high-voltage signals of emotional stability upward.
Precisely. So if a person isn't consuming enough tryptophan, that entire communication pathway just collapses.
Because the hardware simply lacks the power source.
Right. The biological consequence is a severe serotonin deficit, which of course manifests outwardly as those rapid, unexplained mood swings we were talking about.
It's like trying to run a high-powered, super complex app on a smartphone with a dead battery. You really can't blame the software for crashing if the hardware itself has zero power.
That's a perfect analogy.
Yeah.
And this physical reality completely invalidates the most common cultural advice we receive for bad moods, honestly.
Oh, you mean the whole think positive movement?
Yeah. The clinical data heavily critiques that exact mindset. I mean, cognitive reframing and psychological therapies, they are incredibly powerful tools for managing trauma or ingrained behavioral patterns. But it is biologically impossible to outthink a physiological deficit.
Right. If you don't have the serotonin, no amount of deep breathing or positive affirmations is going to magically synthesize it.
Exactly. If the molecular building blocks are missing, your brain physically cannot maintain an elevated baseline, period. Think of your body as an ultra-luxury automotive plant.
Okay, I like this. So the luxury car is what? The stable, happy, emotional state?
Yes. The luxury car is the stable mood. The factory workers are your gut microbiome. And the raw materials, the steel, the engine parts, that's the tryptophan.
So telling someone to just think positive when they're depleted is basically like being a frantic factory manager constantly yelling at the workers to build more cars, even though the delivery trucks literally haven't brought any steel.
Exactly. It's absurd when you look at it mechanically. And this actually requires a very specific redefinition of terms that the sources emphasize today. Specifically, the fundamental distinction between a mood and an emotion.
Right, because we tend to use them completely interchangeably in everyday conversation, but biologically, they're totally distinct things.
The difference is foundational. So a mood is a temporary state of mind, but it is deeply, deeply dictated by your underlying neurochemistry. It is your biological baseline.
Okay.
An emotion, on the other hand, is a strong, complex psychological and physiological feeling deriving from your circumstances, reacting to that baseline.
So a massive aha moment for me, and the analogy that immediately came to mind is meteorology.
Oh yeah, break that down.
So the mood is the underlying chemical weather system, the atmospheric pressure, the humidity, while the emotion is the specific lightning strike that happens because of that weather system.
That is exactly what the clinical data supports. If your gastrointestinal tract is not producing serotonin due to a lack of precursors, your mood weather is highly volatile. It is this dry, electrically charged storm just waiting to happen.
And in that volatile environment, some tiny inconvenience like spilling your coffee acts as a catalyst. It creates a massive lightning strike of emotion, just intense rage or totally disproportionate despair.
But if you supply the precursors and actually stabilize the mood chemistry, the atmospheric pressure normalizes.
Right. You spill the exact same cup of coffee, and instead of a lightning strike, it just generates a mild breeze of annoyance. The circumstances didn't change at all, but the biological environment dictated the intensity of the reaction.
Which perfectly demonstrates why simply telling someone to take a deep breath and cheer up fails. We have to actually deliver the tryptophan to the system.
Okay, so how do we actually get the delivery trucks back on schedule for the listener? Because the research introduces a pretty significant mechanical hurdle here. Simply eating tryptophan isn't the whole solution, is it?
No, unfortunately, it's not that simple. If you eat a meal that's really heavy in tryptophan, say pastured eggs or turkey or pumpkin seeds, those foods also contain a myriad of other amino acids. And that creates a massive metabolic traffic jam.
A traffic jam. Okay, explain that.
Well, the central nervous system is highly regulated. For tryptophan to be utilized by the brain, it first has to cross the blood-brain barrier. The issue is that tryptophan is a large, bulky molecule.
Right.
And it has to compete with other large neutral amino acids, or LNAs, to get through the exact same transport channels.
It's like trying to get an oversized truck through a single toll booth during rush hour. If the highway is clogged with all these other competing amino acids, the tryptophan is just left idling in the bloodstream.
Exactly. So the solution that the sources outline is a highly specific fast-breaking strategy. It's designed to artificially clear that cellular highway.
Right, Protocol 1.
Protocol 1. To ensure the tryptophan actually reaches the brain, it must be paired with a small, controlled amount of complex carbohydrates, like, say, a handful of blueberries or a small portion of sweet potato, specifically when you are breaking an overnight fast.
The mechanics of this absolutely fascinated me, especially given how aggressively carbohydrates are demonized in modern diet culture right now.
Oh, completely.
But the function of the carbohydrate here isn't energy at all. It's acting as a biological routing system. You're basically telling me the carbohydrates are acting like traffic cops.
Yeah, pretty much. The consumption of complex carbs triggers a minor controlled release of insulin. Now, we generally think of insulin solely in relation to blood sugar, but fundamentally it is a storage hormone. Its role is to pull nutrients out of the bloodstream and shuttle them into cells.
And its specific interaction with muscle tissue is the key to clearing that toll booth, right?
Exactly. When insulin is released in this controlled manner, it preferentially targets those competing large neutral amino acids and pushes them straight into the muscle tissues for repair. But crucially, tryptophan is largely immune to this specific insulin-driven transport.
Wow. So the insulin pulls all the competing amino acids off the highway, routes them into the muscles, and just leaves this completely empty VIP lane for the tryptophan to travel straight to the blood-brain barrier.
That's it exactly. By strategically pairing the amino acid with the carbohydrate in the morning, you ensure the precursor actually arrives at the neurological manufacturing centers. Instead of just circulating unused in your blood, it optimizes the physical delivery of the raw material.
That is just brilliant. But even with a clear neural highway, the gut still has to initially extract and process that tryptophan in the first place. And the sources point out a huge vulnerability in this process, the state of your autonomic nervous system.
Right, protocol 2.
Yeah, because if the body is operating under stress, it doesn't matter how perfectly optimized your fast-breaking meal is, right?
Not at all. The nutrient absorption rate just plummets. The autonomic nervous system operates in two primary states: sympathetic dominance, which is your classic fight or flight response, and parasympathetic dominance, which is the rest and digest state.
And modern life, the incessant notifications, the demanding emails, just chronic low-grade anxiety, it keeps the average person pretty much locked in a state of sympathetic dominance all day.
Constantly.
Yeah.
And the physiological response to that stress state is to divert resources. If your brain perceives a threat, it redirects blood flow completely away from the gastrointestinal tract and pushes it toward your extremities for physical survival.
So the digestive system is essentially just powered down. The factory doors are locked.
Literally lock. The gut cannot extract the tryptophan, those enterochromaffin cells can't convert it to 5-HTP, and the entire serotonin production line just grinds to a halt. You can consume the perfect nutritional profile, but if you're stressed, the materials just pass through you unabsorbed.
Which necessitates some kind of physical override mechanism before you eat. And the sources detail this incredible method of vagus nerve activation via deep diaphragmatic breathing.
Yes. The protocol is very specific. You sit perfectly still before your meal. You inhale deeply through the nose for 4 seconds, actively expanding your stomach like a balloon. You hold that for 2 seconds, and then you exhale smoothly through the mouth for 6 seconds. And you do 5 rounds of that.
Now, I have to admit, I initially questioned this. Can just 5 rounds of breathing really be enough of a physical override to flip the switch from a stressed out fight or flight state to rest and digest? It sounds a little woo-woo.
And that skepticism is super common, mainly because breathing exercises are usually framed as these purely psychological calming techniques, like just relax your mind.
Right.
But the clinical focus here is entirely on mechanical physics. It's not about the mind at all. It is about applying tangible mechanical pressure to a nerve.
That distinction is everything.
The vagus nerve runs directly behind your diaphragm. So when a person is stressed and doing that shallow chest breathing, the diaphragm barely moves. But when you actively expand your stomach like a balloon during that 4-second inhale, you mechanically force the diaphragm downward.
You are quite literally physically massaging your vagus nerve with your internal organs.
Exactly. That physical expansion and compression acts as a localized, high-priority safety signal. It communicates directly to the gut that the physical environment is secure. The mechanical stimulation basically forces the nervous system to shift into parasympathetic dominance.
So the blood flow returns to the gut, the enzymes activate, and the factory doors unlock to extract the precursors. It's a deliberate hacking of your body's alarm system using nothing but lung pressure.
Beautifully said. But we still have one final piece of the puzzle. The raw materials are secured, the highway is cleared, the gut is primed. But the actual instances, the final conversion of that tryptophan into serotonin requires a catalyst.
Right, protocol 3, the main power switch. And this blew my mind, honestly. Nutrition provides the substrate, but environmental light provides the ignition.
Yes. The conversion of these neurochemicals is heavily regulated by your circadian rhythms.
So the data is basically dictating that morning sunlight exposure is absolutely non-negotiable if you want this enzymatic conversion to happen.
It is non-negotiable. Unfiltered morning light carries specific wavelengths that strike the retina in your eye. Your retinal ganglion cells then take that and transmit a high-voltage electrical signal deep into the brain, specifically to a region called the suprachiasmatic nucleus.
The suprachiasmatic nucleus, got it.
Right, which functions as the body's master biological clock. When it receives that exact light signal, It initiates this massive cascade of enzymatic reactions that ramp up your serotonin production for the rest of the day.
And the methodology the researchers provide is very strict here. It's 10 to 15 minutes of outdoor sunlight exposure within 30 minutes of waking up.
Right.
But the detail that stood out to me the most was the absolute prohibition of glass windows.
Oh yeah, this is where so many people get it wrong. The assumption is that sitting in a sunlit kitchen or a really bright office yields the exact same biological result. But that's a complete misunderstanding of light physics.
Because modern glass is specifically engineered to filter out UVB and UVA wavelengths, right?
Exactly. And those exact wavelengths are the necessary biological triggers. If the glass filters them out, your retina never registers the specific frequency required to send the signal to that master clock in your brain.
It's fascinating. The glass is literally filtering out the exact frequency of light your brain needs to start the engines. So the environment might look visually bright to you, but biologically, your brain still thinks you're in a dark cave.
Right, the brain registers it as darkness. The suprachiasmatic nucleus assumes you're still in a nocturnal state. So the enzymatic cascade gets delayed, all that tryptophan you perfectly absorb just sits there unutilized, and your baseline mood remains totally flat.
Your brain is basically blind to the light unless it is raw and completely unfiltered. By stepping outside, you allow those specific frequencies to physically hit the eye, which literally flips the master power switch on your serotonin assembly line.
Synthesizing all this clinical data, a really empowering narrative emerges. Unexplained emotional volatility is not a psychological failing. You aren't weak. It is a biological deficit that can be systematically, reliably corrected.
Which brings us to the word tour for this deep dive, just to make sure you have absolute fluency in your own biology. We've covered mood versus emotion, right? Mood is the weather, emotion is the lightning strike.
Exactly.
Then we have the precursor, which is the raw material, like tryptophan, needed to form the active compound. The gut, which is the entire manufacturing plant where nutrient extraction and neurotransmitter synthesis actually happen. And finally, stable, which is what your chemical baseline becomes when all these protocols are aligned.
It's all about absolute architectural control.
Yeah.
You are not at the mercy of random mood fluctuations. By understanding the mechanics of this gut-brain axis, you can actively engineer your baseline emotional state.
Yeah.
Securing the precursor, using insulin to clear the blood-brain barrier, leveraging diaphragmatic breathing to unlock absorption, and using sunlight as an enzymatic catalyst. These are tangible levers you can pull every single day.
You really can architect a state of profound well-being from the inside out just by supplying your factory with the right materials. It totally democratizes emotional resilience.
It does. It shifts the entire foundation of mental well-being away from this vague concept of psychological endurance and turns it into highly practical, measurable, biological inputs.
Which leaves us with a deeply provocative concept to consider as we wrap up this deep dive.
We have established that up to 95% of your serotonin is manufactured by the living ecosystem of your gut microbiome.
Right, those trillions of factory workers. Exactly. But that microscopic workforce is constantly shifting, right? It changes its composition based on every single thing you eat, the environments you interact with, and the stress you endure.
Constantly evolving.
So the implications of that are just staggering. If your baseline emotional state is being built by trillions of microscopic bacteria, are your daily moods actually yours? Or are they just the consensus of a microscopic ecosystem voting on how you should feel today?
That is a wild thought to leave on.
Something for you to analyze the next time that cause and effect narrative breaks down. Until next time, keep exploring.